Hello, my name is Phillip Clendenin, and this is Lab 2 on Lines of Charge for Physics 2212 at Georgia Tech. In this lab, we are continuing our research or experimentation with the pieces of tape and their electrical charges or fields. However, we are going to be using a more accurate way to discover the charge of the tape, and I will get to that later in the video. Before getting to the recap, let me quickly discuss the formulas that will be used throughout the beginning of this experiment. This experiment is primarily covering forces, specifically the electric force and gravitational force. Gravitational force is simply equal to mg, as we can see on this slide, and then we have both electric force and fields. The primary difference is the fact that the force incorporates two or both charges. Recapping what we already know, we have made the calculations listed on the current slide as well as the information listed in the top left corner to specify dimensions. Based off those measurements, we have the lengths of the pieces of tape to be 18 centimeters or 0.18 meters. The piece of the tape has a mass of 0.18 grams or 0.00018 kilograms, and the distance between the tape was 0.81 centimeters or 0.0081 meters. Below this, we have the calculations for gravity, and because it is very close to the Earth, it is simply equaling mg. Thus, it is equal to 0.001764 newtons. At the same time, because we know that the electric force is equal to the force of gravity due to the tape floating, being in equilibrium, or having a net force of 0, thus we have the electric force of the tape also being equal to 0.001764 newtons. Continuing on to the computational model and coding aspect of this lab, we are focused on finding the value of the charge on the piece of the tape. But this time we're going to be using a much more accurate in terms of the value of our charge. Because we used point charge last time, it's difficult to understand where the electric force is coming from. However, when we took things from a line charge point of view, we took some of the unknowns away. Going more into detail, if we set the piece of tape as equal to a point charge, it is easy for us to calculate knowing that it has come from one position, but there are unknowns that we are leaving out, such as the entire distance of the tape. Here, after all of our closed grip calculations, we have the final charge on the piece of tape being 1.1345 times 10 to the negative 9. And this is when we do a line charge, or when it is spread out over the entire distance of the tape. Continuing on to the more vague details about the closed grip, we have some assumptions that we are making about the entire general situation. First off, we are ignoring air resistance, because if that was a factor, it would be much more difficult to calculate the net force on the piece of tape. Or, better put, because we know that the net force on the piece of tape is 0, if there were an additional unknown force added to the equation, it would make us very near helpless to solve with our current knowledge. Also, we have to assume that with each and every piece of tape that we pulled out or used in this experiment, each of them has equal charges. If they did not, it is difficult for us to make any assumptions on the true nature of why the piece of tape was floating. If each charge is different, we can no longer make assumptions about the outside worlds or its the effects of the tape's surroundings. Because if the tape is lesser charged and it still floats, we know that there is another unknown force acting that we have not accounted for. Lastly, getting to the what if and why questions. When we look at the differences between our calculations for the charge of the tape between Lab 1 and Lab 2, our values are not the same. Originally, this may give one individual pause. However, because we are calculating it in a different manner, this is to be expected. Getting to the why behind these estimates differing, a line charge calculation allows many fewer assumptions. For example, because it is not a point charge and we know how wide the piece of tape is, we can see the effects of the floating tape from different parts of the tape, or almost viewing it as a line of point charges. Because it is a line of point charges, each of these things have different x components, and thus their electric field is in a slightly different direction or different magnitude compared to the others. Although slight, there is a difference between each of these point charges. Thus, this calculation for the charge, although different, is much more accurate because there are less unknowns and it is not coming from one exact place. Thus, it is more reliable in the grand scheme of things. That's all for today. Thank you.